This is the continuation of Cisco Networking Basics class, and we are continuing with Module 8, the Internet Protocol. In this module, we are going to be dealing with purpose of IP version 4 address, during which time we are going to be explaining the purpose of IP version 4 address. And we are going to still cover the IP version 4 address structure, explaining how IP version 4 addresses and subnets are used together. Now, purpose of the IP version 4 address. Now, normally, we all know that in our society, we have identities. And the purpose of this identity is to be able to identify individual so that something that is meant for one particular individual will not be mistakenly be directed at another individual. In the same way, in the world of networking, we require uniqueness of the devices in a network so that any packets or any data meant for particular device will not be mistakenly given or directed at another device. And that is the reason why IP version 4 addressing has been instituted into networking. So each and every host, you know what we call host by now. Each and every host now require a particular address, a particular identity that we can use to refer to it. So this identity is what we call IP address. So IP address is required. Now, this IP address, what is it assigned to? It is assigned to the network interface card that is on our computer. Now, sometimes we may have more than one network interface card on a particular computer, as we have it in servers. So it means that such servers are going to have more than one physical address. Now, this IP, I mean one IP address, because now at this juncture, it is pertinent to delineate between what we call physical address and IP address. IP address is referred sometimes to as logical address, but physical address is what we call MAC address. And physical address is assigned by the manufacturer of the computer. But for IP address, it is assigned by either router, or sometimes it is assigned by the ISP. So a particular computer, and it is assigned to the network interface card of the computer. So for every system on the computer, there are identification numbers. These identification numbers are called IP address. Now, when it was first instituted, the IP address was calculated, the entire IP address assignable. Assignable, they are represented as 2 raised to power n, where n is equals to the bits, and we know our computer is 32 bits, so which means we now have 2 raised to power 32. 2 raised to power 32 as the total number of addresses that can be generated. So these addresses have been used over the time and got to a point that it was noticed that, oh, these addresses are becoming vanishing. So, and that is why another part, another version has been researched and it came about. And that is when we now have another version of Internet Protocol, IP. address. We call it IP version 6 address. So, having known that we now have IP version 4 and it is used to identify a computer on the network, it means that no two computers on the network can have the same IP address, because if they do, it means the purpose of identification is now defeated. So, and that is why they should not. Now, like I said earlier, I said the address is 32-bit, and with 32-bit, it's now broken into 4 parts. If you look at this binary digits, it is made up of 32 digits. So each and every of the bits is occupied, either with 0, which means it is off, the bit is off, or 1, which means the bit is on. So, but if you have to remember addresses for the computers, and you have to memorize this 32 for every computers on the network, it won't be easy. So that is why it has now been divided into 4 parts, 8 bits each, using dot notation. The first 8-bit dot, the second 8-bit dot, the third 8-bit dot, the fourth 8-bit. Now, still, remembering this binary will not be easy for us. So it has now been simplified further, such that each 8 bits, which we call octets, is now converted to decimal. So we now call it dotted set decimal representation. And this is the form we use to represent our IP addresses now, so that it will be easy for us to remember the specific IP address that we want to use. So now let's consider how we can really address computer on the network with the IP address, and that is by treating the packet tracer. Now, this is packet tracer now. This is packet tracer that we are going to use to demonstrate that. Now, for every packet tracer you have this work area, then you have the instruction. Normally, this instruction, the reason why it has instruction is just a guided demo. Normally, you can download packet tracer application and you can work with this on your home, not having any instruction to follow. But because this is a guided demo, that's why there are specific instructions for us to follow. So, and the first instruction says you should open the host. So we open PC 0. Now, if you look at this network very well, we have PC, we have it connecting to the internet, and there is another remote system, which is a server. It is a server, a web server. Just like when you and me, when we connect to the internet, there is a system remotely located somewhere which we cannot see. And that system is what we are communicating with, that is giving us that information that we get displayed on our web browser when we browse. So here, we want to now simulate that, and you'll be able to see. Now, clicking on the PC, we have the interface of the PC. We click on the desktop. Then, clicking on that PC is giving us access to that PC, just like you have access to physical computer. Then, we now want to operate it. These are the different parts of the computer that you can operate. Yes, this is an application that you can have access to. Command prompt. You have command prompt on your computer. Now, if you now want to communicate with the server, here in this case, the server address is 172.33.100.50. So you say ping 172.33.100.50. Normally, this ping that we have issued is a command to know whether you are connected to a particular computer. When you ping that computer's address, if you are connected, you are going to know. Let's press enter now. So if you are connected, you are going to know because we are going to have packet return. You can see we have reply coming from the server. It means we are connected. Now, let me now clarify something which we are going to be dealing with later, but let me just prepare your mind ahead. If you look at this server very well, you see the address for it is www.learnip.com. That's the name of the computer. But if the computer is going to be navigated to by the web browser into which you enter that address, it will use IP address. How it gets that IP address is a topic we are going to be learning later. Now, let's now do pinging again. We don't want to use IP address. We want to use the URL of that server. So we say www.learnip.com. If I say enter, it will give us the same result as we have it for when we use the IP address. But first, before it will be able to work on it, you see that it didn't take this time, this long, when we use the IP address, because the IP address is direct. But now that we are not using IP address, it will first resolve this URL. Oh, if you look at it, I made mistake. It is 4W that I use. Let me do it again. Ping www.learnip.com. Then I hit enter. You see that 4W before. That's why it didn't work fine. Now, this time around, you see that it's still taking time. The reason why it's taking time is it has to resolve this www to IP address first. So by the time it finishes addressing it to IP address, then it will now contact the IP address. You can see it's taking time. It's taking time, but it will eventually go after resolving it to the IP address. Now, while that one is busy, let's see, it says after pinging, then it says close the command prompt. Cool. Now that the command prompt is not forthcoming, is delaying us, let's close it. Oh, it says ping request could not find host www.learnip.com. Is that not the address that is there? That's the address. Not to worry. Anyway, let's go ahead with the web browser part. Now, when we open the web browser, we use the same address 172.33.100.50. Now, before we do that, let's first do www.learnip.com. Then we say go. learnip.com. We say go. Now, Actually, the reason why it's taking time to respond now may be due to a lot of things. This DNS server, the actual device that is going to resolve may not be available. So in that case, let's use name host unresolved. Now, the device that is going to resolve it is not available. So we say 172.33.100.50. If we say go now, it will show, yeah, it goes to it. Welcome to Learn IP website. You see, it's able to display it for us. And with that, what message did you see? We saw this is the website that is on that web server, and we have been able to navigate to it. So that is how packet tracer works. I hope you understand. Now let's continue to the IP version 4 address structure. Now we already know the IP version 4 address for easy mapping. We have broken it into 4 octets. Each and every part is called octet. Now, this IP address, there are 2 parts to it. These 2 parts, there is something we call subnet mask that we normally assign after the IP address is given. These subnet masks, there are different subnet masks. Now we have subnet mask 255.0.0.0. This is a subnet mask. We have another one, 255 dot 255 dot 0.0. Now then we have the third part, 255 dot 255.255.0. Now look at this very well. The subnet mask that is actually assigned is what will determine the 2 parts of your IP address. If you have this first one, 255.0.0, so it means for computers on the same network in that particular network that has this subnet mask, the first octet for all the system on that network must be the same. Then the last 3 octets may now be different. This part must be different. Now for this one that has 255.255, the first 2 octets must be the same in their IP addresses, and the last 2 must be unique. Now, but for this third one, the first 3 octets must be the same, and the last one cannot be unique. Then, if you look at this, this is a network, this is another network. Now, look at this network. You see that the first 3 address is the first 3 octets, 192.168.10, 192.168.10. All of them are the same because they belong to the same network, and that is what we call network address. That is network part of the IP address. Then the last part, which is unique, you see this one is having 99, this is having 11, this is having 22, this is having 33. They are unique because if you assign the same to 2 devices, there's going to be conflict. The two devices will not be part of that network. Now, that part is what we call host part. So we have the network part, we have the host part. Look at this second network too. We have 192.168.5 for all of them the same because they belong to the same. Now the two are now part of a single network. So we call this one subnet, we call this one subnet. So because all the systems here belong together, all the systems here belong together. So we have the network part and we have the host part, which must be unique. So now network and host, and that is what is covered here. With IP version 4 addressing, multiple logical networks can exist on one physical network if the network portion of the logical network host addresses is different. You understand? So what makes them to be part of the same network is that network portion. The network portion must be the same for all the systems in the same network. Look at this. This is the network address, network portion for the first network. Oh, that was even 18, not 10. It was 18. Then this 192.168.5 is the second network portion. So, and they become. So the example shows one physical network and two logical IP version 4 networks. Then another example of hierarchical network is the telephone system. The telephone number, the country code, area code, and exchange represent the network address, and the remaining digits represent a local phone number. You understand? By the time you see a particular address, when you see 080 in the case of Nigeria, when you see 0805, you know you are dealing with clone backup network. When you see 0803, you know you are dealing with MTN network. When you see you are dealing with, when you see 0802, you know you are dealing with Airtel. So that is how it is implemented in telephony system. So for the network, that is how. So at the end, I'll be able to establish that the internet protocol address is for us to be able to achieve uniqueness in our network, so that packets meant for particular end device will not be mistakenly taken to another end device in error. Thank you, and watch out for later modules. By subscribing, you will get notified when it is released.